Okay, so now we've gotten to ratios that are going to be modeling three different quantities, and these are some of my favorite problems, the kind we're about to work on this video. The first one comparing A, B, and C, where we're going to have to know A to B and then B to C. You'd have to find A to B to C. And we're going to work one in a second after that that compares X, Y, and Z. That's a lot more complex, and I think is actually a lot of fun. So here's the problem we have. Find the ratio A to B to C if A to B equals 3 to 2 and B to C equals 2 to 5. And your key you're going to have with these is you're going to need to go ahead and bar model both ratios. And so in fact what I will probably do on most of these is I'll draw me a vertical line, and the reason I'm going to draw the vertical line is because I'm going to put the first ratio, the ratio of A to B, on the left, and then the ratio of B to C on the right. And I'll go ahead and make both bar models. So why don't you go ahead and pause the video and on your own paper. You can also make these bar models, and we'll try to find this ratio. Okay, I hope you've taken some time to actually bar model it yourself. And I'll show you that on mine, for example, for A, I made a 3 to 2 ratio. And for B, or for A to B, I should say, I made a 3 to 2 ratio. And then on B to C, I make a 2 to 5 ratio. And some of you may be wondering why I don't do all this on just one bar model. And the truth is, on this problem I could, but it's going to get us ready for the next type of problem where we will need to set up 2 bar models like this. And the main thing I want us to notice as I look at these 2 ratios is, are my units the same size or different sizes? And the thing we want to look out for that is see which quantity is the same on both sides. And notice that I have B on the left side and B on the right side. And then I notice that B, when I have on the left side, is 2 units, and B on the right side is 2 units, which means since B is the same on both sides and it's 2 units on both sides, then all of my units are the same size. And if all of my units are the same size, then to find the ratio of A to B to C is as easy as just counting the units. And so I notice that A has 3 units compared to B, which is 2 units, compared to C, which is 5 units. And so in this case, I have a very simple ratio. It's 3 to 2 to 5. Unless you're wondering, why is Mr. Oz making us do all this stuff when I could have just counted them? It's because the next problem is going to show you why that's so important. So let's compare X, Y, and Z next. So here's our next problem. Find X to Y to Z if X to Y equals 2 to 3 and Y to Z equals 2 to 3. And so why don't you pause this bar model it and see if you can find out what's so different about this problem. Okay, I hope you've written down your bar model. Why don't you take a look at mine? I'm going to bar model that X to Y is 2 to 3. And then on the other side, I'm going to show that Y to Z is 2 to 3. And let's remember, the main thing about a ratio is that all of my units have to be the exact same size. And if I look on the left where I see that X to Y is 2 to 3, and on the right Y to Z is 2 to 3, something should stand out to me, and that's this, that there is a Y on the left side and Y is on the right side. But when you look at the actual problem, we notice that the Y on the left side is 3 units and the Y on the right side is 2 units. So on the right, the units must be larger than on the left, right? Because for the same number to have a different number of units when you move from one side to the other means these aren't the same size. And so let's think about what can we do if they're not the same size. Well, I know this, I should probably cut them into the same size. And so then we ask our question, well, what can I cut Y on the left into and Y on the right into when they're already cut into 3 units and 2 units that are the same? And this should strike you as being somewhat like, a common denominator problem with fractions, where you're going to look for a common multiple. And so if we have a 3 on the left and a 2 on the right, well, we know the least common multiple of 3 and 2 is 6. And so I can cut all of this Y into 6 pieces, and I can cut this y into 6 pieces. And so now my y units are the same. Now, of course, I have to have all my units the same, so let's go back to the left ratio. Did you notice that I cut each unit in half? If I cut each unit in half on the y, then what else should I do? Well, you may have guessed that I should cut the units in half on the x. Are all my units on the left the same? Well, yes, they are, because I had 2 to 3, now I've got 4 to 6, and I recognize that 4 to 6 and 2 to 3 are equal ratios. Now, over on the right side, we actually tripled all of our units on y. So when I go to z, I should triple the units, right? And so now z is divided into 9 units. And so we had a 2 to 3 ratio, now we have a 6 to 9 ratio, which we recognize are equivalent ratios. And so now my y's are both 6 units, which means all the units are the same on the y's, which of course if x is the same size units as y, and z is the same size units as y, then all of my units are the same size. And this is the point where it gets as easy as counting the units. So x actually has 4 units now. Y has 6 units in both places, and then I'll compare that to z, and z has 9 units. And so if x to y to z, or if x to y is 2 to 3 and y to z is 2 to 3, then x to y to z has to be 4 to 6 to 9. I really think those kinds of problems are a lot of fun, and we're going to do a lot of them, but they are challenging in some ways.